Hi, I'm Debbie Nelson. I'm the contributing editor and project manager with Nixene Publishing here in the United States. And I've been working with Adrian Nixon, the editor-in-chief of the Nixene Journal, and we're doing a series of videos on Graphene 101. Today we're talking with Adrian from Yorkshire, England. Hi, Adrian.
Hello,
Welcome.
Debbie.
My question for you today, we've talked about how graphene is basically removed from graphite. You have a rack of graphite, you have a single layer of graphene, and it's with all the remarkable qualities. So we talked about how graphene is constructed or exfoliated.
Yep.
And so that's from the top down, creating graphene. So the question today is how do you do graphene? How do you create graphene from the bottom up? I've heard about that. Like you're building something. How does that work?
Yeah. That we need to just sort of share my screen. So bear with me while I bring up some slides, and then we'll come back and have another chat.
Okay.
So quite right that there are two methods for making graphene. Let me just hide our videos and then make this full screen. So the two ways are the top-down method from graphite that we talked about in the last video that you've just alluded to there. This time we're looking at a different method, which is called the bottom-up method. This is basically assembling graphene atom by atom. And it sounds like science fiction, but people are doing this on a daily basis, almost routine now. It's called chemical vapor deposition. And there are other methods which we may get time to talk about a little bit later. But for the moment, shall we have a look and see how the chemical vapor deposition method works?
Yes, definitely.
What we start off with is a gas which contains carbon. Now, in this particular case, you can see this molecule here. This is the black sphere is a carbon atom, and then there are four other spheres. These are hydrogens, the white ones, and this is CH4, which is methane, or you probably pronounce it methane in the States.
Mm-hmm.
Yeah. And so normally we can't pull those hydrogens off the carbon very easily. You might be able to get one off, but the next one is really hard, and the last two are almost impossible if you're just trying to grab hold of them and pull them off. Yeah, just my slides going awry, but we'll come to those in a minute. So what's happening here is that if you introduce a metal surface, in this particular case copper, and get the methane gas very hot, then what happens is that the copper surface then helps the hydrogen leave the carbon, and the hydrogen disappears as hydrogen gas, and then the carbon comes down and lands on the surface of the metal, and it adopts the lowest energy shape it can, which turns out to be this chicken wire hexagonal mesh of graphene, carbon atoms connected together. And then once the surface of the copper is covered, then the reaction stops, and so we're left with a one atomic layer of graphene covering the surface of the metal. You then peel off the graphene, or you dissolve away the copper to leave the one atom thick graphene sheet. That's how chemical vapor deposition works. Does that make sense?
Yeah. What happens with the hydrogen in the process?
That's a very good point. It is not just hydrogen. There'll be other reactants as well. There'll be unspent carbon as well, so in all sorts of shapes and forms. That's taken off, and it is just, at the moment, this is just exited through scrubbers and cleaners as a waste gas. And so it's vented into the environment in a safe form. So at the moment, it's a waste product, but as the processing improves and the quantities get larger, they'll start to recover byproducts from that.
And then does the graphene stay on the copper sheet?
Yes, in this particular case, it does stay on the sheet, but then if you put some sticky tape on, you could peel the graphene off, or if you put this in acid won't touch graphene, but it will dissolve the copper. So you end up with the graphene floating on the surface of the liquid.
So the copper is dissolved in that case?
Yep, the copper's dissolved, yes.
Oh.
And actually, people are working on how best to separate the graphene from the copper. This is an active area of research at the moment. Lots of different companies working on this particular one.
Oh, that is really amazing.
But there are some problems. It's not all amazing and perfect. So we need to sort of look at the reality of what's going on. So first of all, can you see this graphic on the left-hand side? This shows what even a really highly polished metal looks like when you put it under a very, very high-powered microscope. It's not perfectly smooth. It contains cracks and
like textured.
It is textured, yeah. It's a bit like, do you have crazy paving in the States? Is that a term that you use? It's where you have misshapen paving stones that you fit together in a random pattern.
Absolutely, yes.
Yeah. And it looks like that. And the graphene will grow over the surface of these smooth bits, but then when it reaches one of these gaps, it can bridge some of them, others it can't. And you end with gaps and cracks. It's called polycrystalline graphene. There's another problem, which is that it's called snowflake deposition, and it means that the graphene doesn't start all from one place. It grows at many different places. So if you can imagine looking out the sidewalk when it's snowing, when it first starts snowing, you'll see patches of individual flakes, which then grow bigger and bigger and bigger, and then eventually the whole surface is covered. Something similar to that occurs. These are called domains of graphene, which will then grow and bump into one another. And then where they collide, you get more discontinuities. So this creates what's called polycrystalline graphene. It's not a perfect sheet. And if you wanted to create a perfect sheet of graphene, this is something called single crystal graphene. This is being made, but the state of the art at the minute is more about making polycrystalline graphene rather than single crystal. So we can make graphene on copper. It isn't perfect, it's polycrystalline, but it's good enough for electronics and various other things at the moment.
Oh, that's very interesting. So when the snowflake deposition happens and it doesn't adjust itself, it just fills in until it can't fill in anymore?
Yeah, and if it's, that's a really good point. It will fill in as much as it can, but there are some little gaps that it probably can't fill in, and then you end up with what's called vacancies. These are holes in the sheet, and then they're like weaknesses, and when you try and peel off the graphene layer from the metal, it breaks at those points, so it's very difficult to remove it cleanly.
I see. So that's some interesting challenges.
Yeah, there are some interesting challenges. One of the places where they're investigating it is a place you know, Debbie, which is the Graphene Engineering Innovation Centre in Manchester. It's called the Geek, G-E-I-C. And they have some of these machines for making one atom thick layer of graphene in the basement, actually just around the corner in there. And when Rob and I are working at the Geek, we aren't at the moment because of the lockdown, but we're usually on the second floor up here. And oh yeah, in America you start off with floor 1, floor 2, floor 3. In the UK we got ground floor, first floor, second floor. So we're on the top floor.
Slight difference. Meet me on the third floor. You know?
Exactly, yes. But the point here is that with Nixene Publishing, we're an affiliate partner at the Geek, and we get to see some really amazing things. One of which I thought you might like to share with everybody. A few weeks ago, back in December, we actually saw one of these pieces of copper foil, but this one was really special. So what you're actually looking at here is a square piece of copper foil, roughly about 7 centimeters square, 7 centimeters by 7 centimeters. And the really clever thing is that this has the CVD graphene covering most of the area of the copper foil. But can you see this edge here? And can you, in particular, can you see this line?
It looks like a place you could peel off or something.
Yeah, well, what you're actually looking at there, that's the bare copper foil. And all the rest here, can you see where the copper foil is slightly more silvery? What you're actually looking at there is a 1 atom thick covering of graphene on the copper foil.
Oh, that's exciting to see, and it seems to be like significantly large. You know, graphene was so expensive and made in very, very small.
Yeah. This is really cool. Hardly anybody will have seen this before. This is polycrystalline graphene. This particular one was made not just on this small piece of copper foil. This was cut from a very large roll. So this is made by what's called a roll-to-roll process, where you unreel blank copper foil and you take it through a furnace where it's exposed to the methane and high temperatures, which lays down the graphene covering, and then it's reeled up at the other end. And you can make CVD graphene like this kilometers long. So this is really advanced commercial stuff that people are playing with at the moment. Cool, isn't it?
Yeah, that's very cool, especially the fact that it's roll to roll. So that's
Exactly, yes.
you can,
And I'll stop sharing there so we can get back and have a conversation again. But that
wow.
you're quite right. That roll to roll thing is really important because this is the basis of continuous production, which is the foundation of um, continuous manufacturing commercial processes. So it's quite important what's going on there at the
That's exciting. Now,
moment. Okay.
all of that and all of that is the bottom up, how it's being built.
Yeah,
Oh,
and this is all atom by atom assembly.
it's incredible,
It is.
really.
There's another way of making graphene by the bottom up way, and this is a piece of, well, this is graphene powder in here from a company called Graphene CR, and this is um, this is graphene that's been made from biochar. So this is the waste carbon from food processing. So it'll be the stalks that are left over in fields. It'll be bits of trees, any organic matter really. And then what you do here is you first of all turn it into charcoal by heating it without oxygen, and then if you then take the temperature up even higher, so probably up to around about 1500, 2000 degrees centigrade, then something similar starts to happen to the, like we said with the flash graphene, the carbon atoms come apart and
Mhm.
then they jiggle about a bit and they recombine, and you end up with again a graphene nanoplate powder that's been assembled atom by atom. Isn't that amazing?
It really is, because you had said with the other process that it took whatever had the carbon in it, and then the oxygen has to go away from it. And this one already had the in the process already had the oxygen out of it,
Yeah,
because you were in the opposite direction.
yeah. And the
Proven it.
reason you want the oxygen out is because it would burn with the carbon and create carbon dioxide.
Oh,
Whereas you eliminate the oxygen and it can't burn and form CO2, so it forms graphene instead. That's roughly what's going on here.
so is that process considered green?
Yeah, this is actually the president of the company actually told me, and I've seen the data to back this up, that it's carbon negative because that means it absorbs carbon dioxide when you look at the whole process, because you're dealing with crop waste. So it's a natural product that you're then turning into graphene with a fairly environmentally friendly route. So yeah, that's pretty environmentally friendly stuff.
Well, that's incredible.
Yeah,
So what an education on creating graphene from the bottom up. We've had a lot of different things we've talked about.
yeah. And there are more, but that'll do us for now, I think.
Okay. Well, great. I appreciate your time, Adrian. You always make everything so easy to understand.